Welcome to 5G Hub. Today we will talk about Narrowband Internet of Things or Narrowband IoT. So I will talk about Narrowband IoT as an efficient solution to connect the devices, and will discuss how the Narrowband IoT offers benefits in terms of quality of service, latency, coverage, and reliability. So the first question is, what is Narrowband IoT? Narrowband IoT is a new technology set up by 3GPP as a part of Release 13, and although it's an integrated into LTE standard, it can be regarded as a new air interface. It's kept as simple as possible in order to reduce device costs and minimize the battery consumption. And thus, it removes many features of LTE, like handover measurements to monitor the channel quality, carrier aggregation, and dual connectivity. Also, narrowband IoT is adapted to work in difficult radio conditions, which are a normal operation area for certain machine type communication devices. So, narrowband IoT is an independent cellular radio interface to target the low power wide area connectivity market. It also will suitable for stationary devices, as it will offer a lower data rate of around 250 kilobit per second for downlink and 20 kilobit per second for upload. Okay, what about the key parameters for narrowband IoT? So 3GPP defined a set of frequency bands for which narrowband IoT can be used. 3GPP 36.101 from Release 13 provides the following bands: 1, 2, 3, 5, 8, 11, up to 70. This was in Release 13, and Release 14 added the band 11, 25, 31, and 70 also. And regarding Release 15, it added 4 and 14 and 71. So here we will see the duplex mode will be FDD half duplex, not full duplex like LTE, and not supporting for MIMO. And also the bandwidth is very low and very narrow. It's 180 kilohertz. The multiple access technique is like LTE in the downlink of DMA, and in the uplink single carrier AFDMA. Also the modulation schemes like LTE QBSK only, not for 16 QAM or 64 QAM. The coverage is about increasing regarding to GPRS is plus 20 dB, and the latency will be less than 10 seconds, and will support also the power saving mode. So here the objective of narrowband IoT is lower cost than the machine type communication, extended coverage, around 164 dB maximum coupling loss or link budget, to be compared to GPRS link budget of 144 dB and LTE 142.7 dB. Also, the receive sensitivity were around negative 141 dBm, and will support long battery life up to 10 years with 5 watt-hour battery. So now we will talk about the narrowband deployment options, how we can deploy narrowband IoT in our network. As you may know, it uses the licensed frequency band, which are the same frequency numbers used in LTE. As the spectrum is a very important resource, narrowband IoT needs to be used as little as possible, 180 kilohertz, and also coexist with already current radio technology like LTE or GSM. So to achieve this, narrowband IoT offers 3 different options. First option is in-band, use a resource block within an LTE frequency band, and standalone, use one of the current GSM frequencies. So still there is a guard interval of 10 kilohertz remaining on the spectrum both sides between, as we have 20 kilohertz for GSM, we will have 180 kilohertz and have a 10 in the left and 10 in the right as a guard band. Also, we will have a guard band deployment is use free resource block within an LTE guard band. So we will have a free deployment for in narrowband IoT. So there are 12 subcarrier of 15 kilohertz in the downlink using OFDMA and 3.75 or 15 kilohertz in uplink using single carrier FDMA. So narrowband IoT utilizes GSM frequency with bandwidth of 20 or 200 kilohertz between guard bands of 10 kilohertz for standalone operation, while unused guard band and the resource block of LTE carrier for guard band operation and in-band operation respectively. This is about narrowband introduction IoT. So thank you for watching and see you in the next video. Thank you.